So in section 3.3, we're going to work on dividing polynomials. Long division of polynomials is the big thing in this section. And we're going to start it with kind of a reminder problem. You don't necessarily have to copy this one down, just maybe kind of follow along a little bit. When you're dividing, if you're stuck doing this stuff by longhand, the first thing you do is you look at these things, right? You compare them. You try and figure out, well, what do I multiply this by to get this? Well, 37 doesn't go into 8, does it? So we make our view a little bit bigger. Does 37 go into 87? How many times? Twice. So I'll put a 2 up there. What do I do now that I have that 2? Multiply. So 2 times 37 is 74. Then what do I do? Subtract. And I get a 3. And then what? Bring the 9 down. So let's stop and take stock of all these different steps. So the first step is we figured. Second step was we multiplied. Third step is we subtract. And the fourth step is to bring down. So, where? So those steps have the summary of father, mother, sister, brother. And then I had a student one time that had a dog named Rufus, and she wanted Rufus in there because you want to repeat this. Okay. So father, mother, sister, brother, repeat. We got to do this again. The first step is to figure. We're going to figure out what we multiply by. So what do you multiply 37 by to come close to, but not over exceed 139? And that would be a 3. I think 3 does that, right? See, 3, 91, 90 and 21, yeah. So 111. So father, mother would be multiplied to 3 times the 37. What's the sister? Subtract. And then bring down. And then repeat. So that'd be a 28. Here's our bring down step. Bring down the 2. And subtract. And let's see. Well, let's see. I need to do a little bit more work here still, right? So what? 7 times that. That should probably work. So it's going to be 210 plus 49 is 259. Can I stop? Well, unless I was going to go to decimals, then yes. That last term is your remainder. So I'll put that remainder over the divisor. So it'd be 23 and 30, or 23 37ths would be what you get there. Subtracting. So 3 minus 1, 8 or 9 minus 1, and then bring down the 2. Okay. Thank you. Appreciate the question. So father, mother, sister, brother, and then repeat. Three minus 1 is 2. 9 minus 1 is 8. It's okay. It's all right. We're good. Now, the thing is, we're going to have to do this process except with polynomials. So this is going to be the most fun that you're going to have in this course. You're going to have more fun than the law allows in 3 states and 4 Canadian provinces. So we'll practice that in just a second. Yes, sir. Oh, yeah. Did you? All right. You got it? There you go. Is anyone else missing one? All right. So let's keep in mind these steps as we work our way through these problems. Now just a quick FYI here, along at the top, I've got three different notations, three different ways that this polynomial division could be expressed. You could have it as numerator and denominator, you could have it as the first one divided by the second one, or the second one into the first one. So, there's a lot of different ways you can write it. All of them mean the same thing. And we're going to do the same thing for all of these, and that is follow along with those 4 steps that I outlined just a minute ago. Father, mother, sister, brother. Now for your father step, you have to look at these leading terms here, this one, and figure out what you're going to multiply by. Now some of you can probably look at this and go, okay, yeah, 2a times 4a squared, that's going to give me my 4a, or my, 2a times 4a is going to give me my 8a squared, so 4a is what I want to multiply by. But when you start getting stuck on these and looking at them and your head turns into a fog, then what you can also do is you can take this and divide it by this. And that you see here. 8a squared divided by that 2a, that tells you that leading term there. So that's going to be your 4a. And we'll put that up on top. So that's the father step. Then what? Father, come on, make me look good. Mother. The mother step is your multiplying. Now when you multiply, it's that 4a times this entire expression out in front. So it's 4a times 2a minus 1. So unlike the father step, which just involved the leading pair, the mother step involves the whole thing. 4a times 2a minus 1 gives me 8a squared minus 4a. So that's right there, like that. Father, mother, what's next? Sister. So our sister step is right here. You're going to subtract this. Now, if you're going to make an error, here's a great place to make the error. All right, and it'll screw you up for the rest of the problem because it's just that way. I'm sorry. But the typical error is that you're good with subtracting this. 8a squared minus 8a squared is 0. But here's where you got to be careful. That negative distributes itself to both terms. So it's minus 8a squared, but what else? Plus 4a. And you can see that with what I've written. 2a plus 4a gives you 6a. So that's where you got to be kind of careful here. Last but not least is the brother step. You bring down that negative 3 there. And you start this whole thing all over again. Kennedy, is that a question? No? Good? All right. So, let's go through this whole thing all over again. So I've got a 6a here, 6a there, and a 2a up front. A lot of you could probably look at this and say, oh, okay, yeah, I get it. I'd multiply this by 3 to get this. And that's fine. If you can read it off from there, power to you. But some of you might want to do this. Take, all right, this divided by that. And that gives me the 3 that I'll put right here. So plus 3. Father. Mother. Take that 3 out in front and multiply by both of those terms here. What's 3 times 2a minus 1? 6a minus 3. Father, mother, sister says to what? Subtract. Now when we subtract, the big thing is to change the signs and adds. Now I tried to subtly draw your attention to that right here because that's the place that people make their mistakes. They don't change the sign on that second term here. When you change the signs and add, what's left? 0. a big goose egg, so it goes in evenly. And that's actually kind of nice. That means you can check your answer. How do you suppose I could check my answer in this? Perfect, thank you. If you multiply those two together, 2a minus 1 times 4a plus 3, you should get exactly what we got here. And I might as well do it out. It's going to be 8a squared plus 6a minus 4a minus 3. And when you combine like terms, yeah, nailed it. All right. So it's nice, especially when those work out. Oh, yeah. Yeah, thank you. Wait, there's a few other people. Thank you. Extra credit, Dwayne. Good man. All right. How are we looking on this first one? Good? Is there something that I went over a little too fast and maybe you want me to go over it again? So this is where you start to spread your wings and fly a little bit. If you notice, I was a lot less forthcoming with the details on this one as opposed to the last one. So we'll start it out together. We'll find out if you really understood this, okay? So remember our 4 steps. Father step, right? You're going to take and divide the leading terms. 6x cubed divided by 3x. 3 goes into 6 twice. Subtract with the exponents. 3 minus 1 gives me 2x squared. So that goes up top. Little trick here. I put the 2x squared right over the x squared term. The reason for that is because if you do that, when you get down to the constant term, that's it. That's where you're done. And if it looks like there's more to do once you get down to the constant term, then you've made a mistake someplace. Father, mother. I'll take that 2x squared and I'm going to multiply it by the entire binomial out in front, which gives me 6x cubed minus 4x squared. So that has to distribute itself to both terms here. 6x cubed minus 4x squared. C. What comes next? It's okay. What comes next? What do I do next? Father, mother, sister. Yeah, subtract. All right, so I want to subtract. And the big step in subtraction that you got to be careful of is to change the signs and add. So that becomes a minus. It's going to cancel out. But negative x squared and positive 4x squared, negative 1 and positive 4 add up to 3. Nice. And last but not least, our brother step. We'll bring down that 4x. All right. Your turn to step it up. We're going to work on the father step, and the mother step, and then the sister and brother. Father, mother, sister, brother. See if you can't get this next step, and then see if you can indeed finish it up. Okay, so to continue this, I'm going to take the 3x squared divided by the 3x. So again, working with the leading terms. When I divide that, I get an x. So that x comes right here, plus x. Multiply by that x gives me 3x squared minus 2x. So let me put that here, 3x squared minus 2x. Change the signs and add. Now, if you forget to change the sign, when you bring this down, you'll have a 2x. And then you'll be looking at the 3x and the 2x and starting to think, oh my God, I need fractions. I'm not going to be that mean to you on an exam. You will not get one of these with fractions. Not that you can't, but I just won't do that. So if you get a 2x here, there's a problem someplace between your paper and the floor. And I'll let you figure out where, but it would be wrong, all right? So this is kind of a friendly little hint. When you change the signs and add, this becomes plus 2x plus 4x becomes a 6x, like that. Last but not least, to finish this up, I want to take a look at, again, the leading coefficients, or leading terms, I should say. 6x divided by 3x gives me 2. And then I do my multiply step. So let's put that plus 2 up here. Multiply 2 times 3x minus 2, and that gives me 6x minus 4. All right. 6x minus 4. Subtract, which means change the signs and add. What am I left with when I do my subtraction? 0. All right, so 0. Nice. Now that's long division. And sometimes you can't avoid having to do long division. It's just annoying. Sorry. But in the right circumstance, you can get away with synthetic division, which is a lot cooler. And we're going to look at synthetic division and do a couple problems. So here's this problem with long division, and I regret that I didn't have parentheses around here, like that. X cubed minus 3x plus 10 divided by x plus 1. Now, you can do this one with regular old long division, and here it is in all its gory detail. But if you're dividing something by x minus a number or x plus a number, then you can use synthetic division. So, for x minus c or x plus c. That's when you can use synthetic division. And synthetic division is really slick. And it's going to become very important for us. So let me run through it and we'll practice it. But notice how much easier this looks than this. I mean, we don't understand this yet, but I don't know. Looks like a lot less work on the right than it does on the left. And it is. Now, one thing we have to notice about this polynomial is that it's actually kind of missing a term. It's not really missing, it's just not written. You can think of that as x cubed plus 0x squared minus 3x plus 10. And I'm going to divide that by x minus 1. But the reason I pointed that out is because you've got to account for all the coefficients of that numerator, or what you're dividing into. So what would the coefficients of this be? 1, 0, -3, and 10. And if you look, those coefficients are right here. So, okay, one mystery solved. Now, let's put a little line here between this and this. This, when you're all said and done, that's going to be your remainder. I mean, these two problems are the same, they just work different. But We know we get a remainder of 8, so we can spot that. That's pretty easy. That's a remainder of 8. For the rest of this is going to be a series of add to go down, and then multiply to go up. So two of those things. Two operations. The one other thing that we got to take account of is this. I'm dividing by x minus 1, but I put a plus 1 out in front. So how do you think I'm going to make the transition from here to here? What's the rule going to be in general? Change the sign, yeah. Change the sign. So if this was a plus 1, I'd have a minus 1 out in front. If it was a minus 8, I'd have a plus 8 out in front, etc. But you're going to change the sign. Some people also like to do this. Just put a 0 there just so that it kind of completes our little add and subtract routine. The way it works is this. Once you've got this all set up and you put your 0 in, you add to go down. 1 plus 0 gives me 1. And then the number out in front helps you go back up. 1 times 1, well, it's again 1. And then this process repeats itself. Add to go down. 0 and 1 gives me 1. Multiply to go up. 1 times 1 is 1. What takes me down? Negative 3 and plus 1 gives me negative 2. And to go back up, now notice I drew that kind of like sideways up and to the right. To go back up, you multiply. 1 times negative 2 is negative 2. When you add, you go down. Now when it's all said and done, you have 1, 1, negative 2, and 8. This is your constant term. That's a coefficient of x. That's a coefficient of x squared. And this is your remainder. So x squared plus x minus 2, remainder of 8. Yeah, you know what? I'll show you as we do exactly one problem. It's problem number 30, and then I'll get you out of here. If you got to leave, try problems 3 through 17 in the homework. But like I said, we'll do one quick problem, number 30. (3x cubed minus 12x squared minus 9x plus 1 divided by x minus 5. So let's see. What am I going to put out in front? Plus 5. And underneath goes all the coefficients, 3, negative 12, negative 9, and 1. Between these last two, let me write a little vertical line there. Why is that? What's that number separated going to be for me? That's going to be your remainder. So add to go down. Now it might help you out if you wanted to. You can start out with a 0 there. Doesn't hurt to put that 0 in. When you add to go down, there's a 3 here. What brings you back up here? What should I write underneath the negative 12? 15. 5 times 3 is 15. Add to go down. 3 again. Multiply to go up. 15 again. Kyle, things are going to start to change here. What do I get here next? 6 and then 30, 31. The important thing when you're done is remember that's your constant term, x and x squared. So what this really becomes is 3x squared plus 3x plus 6. And somebody was asking about this. You can take your remainder and put it over the divisor. All right, for homework, try 3 through 17, and I'll see you next time.